In this session of work energy and power we discuss the potential energy. Observe the motion of the ball. What you have observed. When the ball starts moving upward, its kinetic energy is maximum. As the ball moving upward, the kinetic energy of the ball is decreasing, and at the maximum height h the kinetic energy is 0. Why the kinetic energy of the ball is decreasing? You can think. The decrease in kinetic energy of the ball can be explained using work kinetic energy theorem. According to this theorem, work done by all types of forces equal to change in kinetic energy. During the motion of the ball, only one force is acting on the ball, which is weight mg, vertical downward, by the earth. The work performed by this force is negative, that's why the kinetic energy of the ball is decreasing. Here we are neglecting the air friction. Can you tell me the work done by weight mg? Yes, you are right, the work done by this force is minus mgh. Let me explain. As the force is constant, the work done by the force is Fd cos theta. Here theta is the angle between force F and displacement, which is pi, and the value of cos pi is minus 1. F equals to mg and magnitude of displacement d is h. Hence the work done by weight mg is minus mgh. As the work by this force is negative, that's why the kinetic energy of the ball is decreasing. According to work kinetic energy theorem, this work minus mgh equals to the difference of final kinetic energy and initial kinetic energy. The final kinetic energy is 0 and the initial kinetic energy is half mu square. Hence half mu square equals to mgh. Here u is the initial speed of the ball with which it starts moving upward. But there is another way to explain this happening. As the ball moves upward and its position is changing, kinetic energy is converting into another type of energy. When the ball is at the highest point, the energy of the ball has the potential to become kinetic energy, if the ball is allowed to fall. For this reason, energy associated with the position is called potential energy. Our discussion suggests that there is a potential energy associated with the weight of the ball and its height above the ground. We call this gravitational potential energy. The previous discussion indicates that, at the maximum height, the initial kinetic energy is completely converted into the potential energy of the ball. From work kinetic energy theorem, we have proved that the initial kinetic energy of the ball is mgh. Now we define mgh as the gravitational potential energy associated with a particle plus Earth system, depends on the height h relative to a reference point. There are some important points for mgh. This expression is valid when g is assumed to be constant. Here h is the height of center of mass of the body, relative to some reference point. You can choose this point wherever you like. Above the reference point, gravitational potential energy of the body is positive. Below the reference point, gravitational potential energy of the body is negative. On the reference point, gravitational potential energy of the body is 0. Now we observe the sum of kinetic energy and potential energy. At the initial point, the kinetic energy is half mu square and potential energy is 0. Hence sum of kinetic energy and potential energy is half mu square. This energy is mgh according to work energy theorem. At this intermediate position above the height h1 above the reference point, we calculate the sum of kinetic energy and potential energy. The work done by mg equals to minus mgh1. This work equals to change in kinetic energy that you can see. From this equation we can observe that the sum of kinetic energy and potential energy at this position comes out the initial energy. At this final position the sum of both energy is mgh. Hence the sum of kinetic energy and potential energy of the ball plus Earth system is constant. The sum of kinetic energy and potential energy is mechanical energy. The mechanical energy of ball plus Earth system is constant, when only the force of gravity does work. This is called conservation of mechanical energy.